Hello and welcome to my talk about DriftlessAF. Driftless is a agentic reconciler framework that's proven at scale by ChainGuard that we open sourced at DriftlessAF.ai, and I'll tell you all about it today. I recently presented about the question if DevOps is doomed in this AI age where the supply chain risk is getting more and more. The AI-assisted development is getting faster and faster, more and more apps out there, and this is all questioning the future of DevOps also in the light of Mythos and other models being able to chain attacks more and more. And this adding the AI to this existing mess of the supply chain and DevOps tooling and software development seems to make everything even crazier, and lots of people seem to be thinking that this is all doomed to fail. I will talk to you more about DriftlessAF and how we found that that's not the case at all. You just have to adjust and have a workable framework that can help you with this. So DriftlessAF is a agentic reconciler framework. Open sourced at DriftlessAF.ai under the Apache license. You can check out all the code there, and we'll talk about more what this means, but in terms of available code. But let's talk about what an agentic reconciler framework even is. Driftless, the name means that there is no deviation from a desired state. And our desired state in our tooling is typically there's no CVEs, it's the latest version and stuff like that. And the desired state is re-established and monitored by an agentic framework. So we have traditional bots and we have reconciler bots that are agentically powered. So they use models to create the right code. They use models to monitor each other's output, ensure quality, write more tests, improve the code, and so on. The reconciler pattern is something you might all know from the Kubernetes ecosystem, where the control plane basically monitors for the desired state being, like this container should have so and so many instances and should be configured network-wise this and that, and the database should be over there. The control plane will make sure. So if someone changes the desired state to have more containers, it will scale up, or if it's less pods, it will scale down. And we adjusted that to software development powered by AI as well as other tools. So what are some reconciliation examples that we tackle in DriftlessAF? Typically we work on GitHub pull requests that change our packages or our code, and we work on that in pull requests, but also work with issues and then content in general in GitHub repositories. And so here are some examples. For example, we could ensure that a package we do build for our ChainGuard OS is using the latest release that's available of the upstream open source project. We get those via feeds, and the reconciler then could potentially make sure that it's updating that. It could do simple things like verifying the PR title or the description or the commit messages have the right content and are filled in and follow our conventions. So automatic release nodes composure works, for example. It could enforce test coverage. It could change the actual source code or configuration files to follow best practices such as compiler flags being set, certain shell commands not doing things that they're not supposed to, and so on, all the way down to patterns being implemented correctly in our Go code base. So why did we even build DriftlessAF? We had our old platform that used an event-driven pattern, and it worked well, but at the scale we were getting to, it just didn't work so well anymore after all. We had event drops and missed package updates or failed builds, and engineers just ended up constantly being on call for work that really wasn't that complicated, but there was just so much of it and there was no automated way to fix them. And because our scale got bigger and bigger and open source projects develop more and more releases, there's more and more of them that our customers want in terms of containers, we just couldn't keep up. And at the same time, the cadence we needed to release also became more and more critical to be like near zero, right? Like our SLAs for customers got dropped down more and more because customers demanded more and more security. So we had to get down to like hours and not months of delivery. And so we needed to figure out a different pattern, and reconciliation seemed to be a good thing from our experience with Kubernetes. So we tried, and that seemed to have worked so far. So how does this all work in terms of what you even get with Driftless? You basically get a complete framework. We have Terraform recipes for Google Cloud deployment. It could be deployed in other systems as well, but we just happen to be using Google Cloud and using Terraform. So that's what we open sourced. We have a full work queue, the management tools, the observability, and the dashboards within Google Cloud, all reconfigured and ready to go. So you can manage the system once it's up and running. We have a separate included agentic AI framework that helps us with a whole bunch of aspects of working with different models, working with the different tasks they need to do, and so on. There's a whole bunch of reconciler bots that are available, some of them are fully usable, some of them are code examples that teach you how to write more, and the whole system is written in Go, so you can expand it as you like. Let's look at some of the core components of DriftlessAF. First one is the work queue. It stores individual tasks in the work queue in GCS, or Google Cloud Storage System buckets. Each individual task is basically identified by a URL. So for example, a URL to a pull request, and the status data is just JSON objects that are stored. The system is very resilient and scalable because it can be optionally sharded and use multiple regions, and therefore it's just also very stable because it's just files in the object storage that can get moved around. And by moving around them in different locations in the object storage, we also track status. So there's queued, in progress, and dead letter states that are just prefixes on the object storage. The system automatically does prioritization and can also do retries as needed. And the dispatcher just takes the items from the work queue, hands them to the reconciler bots to do their work on a specific PR, and they can be farmed out completely in parallel to be processing all sorts of PRs, even the same PRs at the same time for different tasks, and collaborate with each other. So very, very scalable. For an agentic framework, the agentic AI infrastructure is obviously an important core part as well. And let's talk about the models and prompts that the system is using and can use first. So we have a meta agent layer because the different tools and models are providing different benefits, and ultimately you want to be able to not have to code in your reconciler bots to a specific model. So we have that meta agent layer. Currently we use Gemini, Claude, and OpenAI, and we can expand that to further models as well. The executors within the AI framework manage the conversation with the LLM, so it's not just a prompt and then the work comes back, but there's literally a full workflow, just like what you would normally use Codex or Claude manually, where you like interact with the system. In this case, the reconciler bots work with the LLM and have a full conversation essentially. One of the aspects is we include a secure prompt builder. Think of it as a similar system to how SQL queries can be set up and just parameterized and immutable, so there's no security issues because you're just passing over the parameters, and those parameters are strongly typed. So that prompt builder is very useful. And for more complex data, it supports bindings dynamically via JSON, XML, and YAML files. So whatever the originating system and data is, there isn't too much manipulation necessary. You can sort of pass it straight in. Another important aspect of every AI infrastructure, obviously, tool calls and evals. The tool calling mechanism is abstracted again as well, so that the different models and the different tool calling mechanisms are not leaking into our system. So we abstract all those away. And the agent evaluation framework basically tracks how the agents historically do their work, how long they take, what cost there is, how good the quality is. So we have a judge, which is another LLM system and invocation that judges the LLM output from other agents. So for example, we have like if an answer, like in a simplified manner, say you pass in an addition and the addition or mathematical operation that you pass in comes back with the exact right answer, well, that's sort of like a golden response. And then we have more levels of lesser quality. And so that judge can also be used to track that quality of response over time, which then is used to sort out our choices on new models or different configurations, different prompts, and so on. For even more advanced use cases, we also support a RAG process where we use that historical data for improving the overall call and for improving repeated invocations of the same tasks. Specifically, for example, as an example, the CV remediation I mentioned before, if you already specifically developed a patch that works for a older minor version, if you do the same patch for a different minor older version, it's going to be able to apply that patch easier and cleaner and faster if it uses the information from last time it tried and struggled through multiple iterations. So that's very useful for scaling that. And with all that work also comes a lot of observability. So the tracing and monitoring information goes from our system into the models all the way to the tool calls, so we can really understand how useful this works and how performant it is. As a next step, let's look at some of the GitHub reconcilers that we have included in DriftlessAF and what they do. So they use very robust authentication and commit signing, obviously, and we support GitHub pull requests as well as GitHub issues. So these pull requests and issues can be inspected and can be modified. You can find, locate them, create new ones, update ones, but also close them, get them to merge, and so on. All that can be done in a nomadic fashion by agents. The metadata that's sometimes necessary is just Go templates that are provided and used as structured metadata, and they get put into the description, often as hidden file or visible, and then the operation can be passed through and move that information on. Also, because we're operating at really large scale and we're working essentially on a lot of Git repositories, we have a pooled management of the different clones, because if you keep doing a full clone of a repository across the cluster in all the different ways where you operate, this gets very expensive. So we have like a clone management that's like storage separately, and you can reuse those clones rather than cloning from upstream all the time. When it comes to file changes from these GitHub reconcilers, we support file path analysis as well as file modifications themselves. So you can look where files are and then modify them. So we can obviously deal with source code, but also test source code, config files, and other aspects. And when a file then is changed and GitHub does its check runs, whatever they may be, a full CI/CD pipeline or some other simpler stuff, the status reporting gets back into the reconciler bots and takes them into account and triggers off the next runs. Beyond these GitHub PR and issue reconcilers, we also have a bunch of others. Let's call out here a few. One is the linear reconciler. So that's linear issue tracking system. Is something we use that does similar things. So you can reconcile the state of a linear issue with associated PR, for example, or you can make sure that the description is filled in correctly, it has all the right information, the title is correct. And we also do APKs, so Alpine Package Management, Linux packages, which are used in Chainguard OS. So you can reconcile those, so you can adjust their manifests and other metadata and make sure it uses the latest version, the correct package metadata, and so on. And we also work on OCI container images, including all the OCI different layers, and you can reconcile to new container images that use the right layers and are composed of others, and so on. Last but not least, and useful for you to have a look at the code, are a few example reconcilers. So we have the GitHub PR, validator and autofixer, the issue materializer, and the path modernizer. So I'll show you a demo shortly of those. The PR validator can just validate a PR's title and description. The autofixer can then fix, like automatically use an LLM to improve them and fix them. The issue materializer can create a new issue with description and so on, related to something that it finds. And last but not least, the path modernizer can improve Go code itself. All right, let's look at a DriftlessAF example repository I have here, where I have a very simple README that has some text in it, and I have a couple of pull requests slash a new pull request here that just adds text to this README file. So if I create a new pull request here for these different branches, and I'll just like leave it empty like that. I'll create another pull request for the more info, and finally I create a pull request for the Confidential Computing Summit text entry. I'll have these new pull requests. So you see I have 4 new pull requests created, and all of them already got assessed. So if you look here, the PR validator found 2 issues. The PR validator found the issue that there's no title and no description. That's because I was just lazy and I just used the commit message for the PR, and this repository slash the PR validator requires conventional commits. So I could go in and fix this now, or, and this is what's indicated here, I can also rely on Driftless to do this. So if I add this label, DriftlessAF autofix, DriftlessAF will go in and fix it. I can do that to the other PRs. You can see here, this one has the same issue. Looking at the PR validation, same thing. So I'll add the label. And now you see the PRs are being processed by the autofixer. And you see here the link title, or the title for this PR, was already changed by the autofixer. So if you go in now and look, you also see that the PR got a description now that I did not provide. This was generated by one of the reconciler bots, specifically that autofixer reconciler bot, that used an LLM to create this message, which just looked at like the content itself and came up with a message. If I go back to the others, you see this one was also fixed now. The ones that do not have the label did not get fixed, and I can just apply those as well. And that same mechanism of pull request getting automatically fixed can be something that also touches configuration files and code, Go code or whatever. And so DriftlessAF can essentially make your pull requests better and better and better until they pass a CI, and then it can also potentially merge them and move on forwards. Here's an example of what it would, for example, do on a Go modernization with the Go reconciler. So you see here there is a Go snippet that doesn't do the error messaging correctly, because what it does is it just uses like numbers, which are like magic numbers, right? So, and instead it uses the actual HTTP class static fields that define those numbers. So you see it's much more readable for someone that doesn't necessarily know all the HTTP error codes automatically. It's like HTTP status okay is 200. Status not found is 404, right? Status unauthorized is 401. That's already someone that might not know. And then when it gets to like a whole lot of other numbers, people might not necessarily know. Well, this makes the code more readable and improves it automatically. And DriftlessAF can do that for you. So now that you've seen what Driftless can do overall in a sort of like framework kind of level, let's talk about what we do at ChainGuard with. So we have this ChainGuard Agentic Factory, which basically builds open source projects from source and works around the fact that the typical software supply chain is not secured. We replace the whole build pipeline, the dependencies pulling in, the distribution, and we build containers, packages, and libraries for your team based on what comes out of the ChainGuard factory. And by doing that, we can prevent malware, we can add SALSA level 3 attestation, we can add provenance information and so on, all in the ChainGuard factory. And in the ChainGuard factory itself, we have DriftlessAF doing the work. So we watch a whole bunch of open source projects of feeds. So we watch GitHub releases, we watch the public registry feeds. So if new packages become available in Maven Central, PyPI, or the NPM registry, we monitor a bunch of websites that expose end of life and release information. We monitor all the security feeds and CVE feeds. And all of those trigger changes and events into our work queue. And then the reconciler loop in Chain Factory, powered by DriftlessAF, runs things like update bots, autofixer bots, malware bots, and each one of those bots kicks off an agentic loop that does things like checking if there's new versions, fixes code so that CI fixes. If the CI fails, it looks at the log and analyzes that. It fixes CI CD, and so this whole loop ends up running through all in parallel. So for example, if a package is updated to a new version, that package availability of that new version then triggers another reconciler for all the container images that use that package. So we constantly have these floods of changes running through the factory where packages get updated because open source projects cut new releases, and then the updated packages flow in containers, and then those containers potentially trigger other containers or Helm charts and so on, right? So our factory basically produces all these artifacts, and they include SALSA level 3 provenance information, SBOM data, 6-door signatures, and so on. So, and because DriftlessAF is moving a lot of this in parallel, our patches and artifacts become available very, very quickly. Here you see another visualization. Again, we have these AI bots that do version discovery, that fix it. We have the Quackage improve bot that does literally like write more testing cases and improves the testings setups that are already there. And all of this works to produce those binaries you get. The scale that we are operating with DriftlessAF in Chain Factory is pretty amazing. Over 2,500 container images, different variants of all sorts of things, base images for runtime environments like Java or Python, or all the way to like full-on applications, Argo or whatever else. Over 2,500 different ones of those are kept up to date 24/7. We have over 600 million container builds we've done. There's over 240,000 container versions, and we remediate lots and lots of CVEs all the time as well. We build APK packages, NPM packages, Python wheels, Java packages, and of course the container images all day, every day. So what did we get out of DriftlessAF in terms of winnings when we started moving from the old framework to the other? Well, lots more stability and throughput. For example, when the Python fixer landed, we immediately got over 2,100 PRs out of just fixing up Python packages, and that ended up costing about $7,500 of tokens, and then the PRs just had to all get reviewed and merged, but that was pretty quick to do, and we got a lot of improvements out of that from DriftlessAF use. The test quality and coverage also dramatically increased. For example, one of the initial prompts that we added in one of the reconciler bots triggered 900 PRs in like one day once that prompt was activated to improve tests. Version discovery of new releases also ended up getting to like 100% coverage, where before we had like failures and like missed versions updates. And of course, we build a lot more libraries and packages from source now. So let's talk about what else could be done and Driftless could be used for. Obviously, it could be deployed on-prem or at different cloud providers. We could adjust the Terraform recipes and that kind of setup. It could work with other Git or other version control systems, GitLab and others come to mind. Obviously support different issue trackers. We have GitHub issues and Linear for now, GitLab issue tracker, Jira, whatever, there's lots of them. We already have more reconcilers for other languages internally, but those could also be expanded and do things like, modernizer reconcilers that modernize a code base from an old version of Java to a newer version or whatever else. There's lots of things that can be done. Obviously, the code generation for upgrades could also be improved, and you could even create reconcilers that look at the code to create documentation or testing and so on. So there's lots of things you can be doing with Driftless if you are so interested. Here are some projects that already do use Driftless. Obviously, a Chain Factory. There's also Code Reviewer, which is a command line tool to basically initialize a code review, and then Zen, which is a project from Maxime as well, one of our engineers, that allows you to work with lots of PRs in the same time. So DriftlessAF causes a lot of those PRs, but then also helps you work with those PRs. And your project could be next. Couple of resources, DriftlessAF.ai is the website. This then just links to the GitHub organization. You see there's 2 repositories mostly there. The Go DriftlessAF repository that contains all the reconcilers, the work queue, and the whole infrastructure and everything. And Terraform, just the recipes to get it deployed. There's also additional docs available with the agent helper, so you can literally ask questions to it on the CodeWiki from Google. Under those 2 URLs. That's it for Jenga Factory. As you can see, the Jenga Factory is very busy and does a lot of work, but we also need more people to help us. So we're always hiring. So jenga.dev/careers is where you can find out more about that. And that's it. Thank you so much. Hope you learned something about Driftless and how even though AI feels like threatening to lots of people, in the end, it's a tool and you can use it to do a lot of good work. For example, with Driftless.